starting with a short lecture, and then we're going to move on to the quiz. So I'll hand out a quiz, which should take you no more than 15 minutes, but you will have the option to work on it longer than that if you want. And then once you're done, you'll come hand your quiz in to me, and I will hand you a Chromebook from the cart. And when I hand you your Chromebook, you'll go up to the board, put your name and the number. There's a little sticker on each Chromebook. Put your name and the number. And then you'll work through the activity that's in your packet of notes at your seats. And when everybody's finished with their quiz, then you can discuss the activity with your group. So the activity is going to be using a program called Geogebra that I'll be showing you how to use in the lecture. So any questions about the course of events? So I put the sign-in info for the Chromebooks on the board. So if you have any trouble with it when the time comes, just raise your hand and I'll come help you. Yep. It's yeah. No, you can use your own. That's fine. But put your name on the board and write none or something, just so I keep a record of who has what. Oh, and if you have a laptop, you can run Geogebra on a laptop too. It doesn't have to be a Chromebook. So if you have your own laptop, you can use that. All right, so let's take a look at class 4. So the beginning part of this is like super duper review. We're just talking about the coordinate plane. It's also called the Cartesian plane because it was named after René Descartes, the inventor. So here's a picture of a coordinate plane, several points plotted. Quick review of everything that you remember about the coordinate plane. It's an x-axis and a y-axis. Those two axes meet at what point? 0, 0, and it's called the origin. There are 4 quadrants, 1, 2, 3, and 4. And you plot points by going horizontal and then vertical, right? So if I wanted to plot 2, -4, I would go right 2, down 4. This is familiar to everybody? All right, good. Let's move on. Okay, so we use the coordinate plane as a tool to help us visualize a relationship between 2 variables. Those 2 variables we often call x and y. A graph is just the set of all points x and y that satisfy the equation. It's the set of all values of x and y that when you plug them into the equation, you get a true statement. So today we're going to learn several methods for generating and analyzing the graph of an equation. You can graph by plotting points, right? So we make a little table of values. Choose some x values. I chose a few for you for this first example, and then just plug them in. So if we do 4 minus -3 squared, what do you get for y when you plug in a -3 there? 4 minus 9, which is -5, which means that a point on the graph is -3, -5. So we can plot -3, -5. I did another one for you down here, so we have 0, 4. And you can just pick x values, get y values, and plot points. So for -2, I would end up with 4 minus -2 squared, so that's 4 minus 4 is 0. So -2 zeros on my graph. Left 2, up and down 0. Everybody done something like this before? Graph by plotting points. So this one ends up looking like this, and we get this sort of upside down parabola. So I'm not going to have, we're going to skip this because I just want to make sure that this is short enough so that we have time for the quiz and the activity. It's just another example of the same plotting points. Did I skip anything over here? No, okay, good. Okay, so finding the x and y intercepts of a graph. The x-intercepts of a graph are the places where the graph crosses or intercepts the x-axis. And similarly, the y-intercepts of a graph are the places where the graph crosses or intercepts the y-axis. So let's identify the x and y intercepts from our first example here. What are the x-intercepts of this graph that I graphed here? 2 and -2, and what's the y-intercept? 4. Awesome. So x-intercepts, places where it touches the x-axis, -2 and 2. Y-intercept, where it touches the y-axis, 4. So let's see, we'll write that down. X-intercepts are at positive and -2, and the y-intercept is at 4. Now, those are actually points, but I only wrote down one number. So how do I know what the point is if I only gave you one number? Where on the graph that point is? Yes? Yes, you know it's on an axis, so you know the other coordinate is 0, right? So the other way I could have written this for my x-intercepts, I could have gone plus or minus 2, 0, right? Left 2, 0, up, and right 2, 0, up or down. And for my y-intercept, I'm on the y-axis, so that's my y-coordinate, and my x-coordinate is 0. So both ways are acceptable as inputting answers. Just pay attention in my math lab. They probably will tell you what format to write it in. So how could we have found those special points, the x-intercepts and the y-intercepts, algebraically, without having to draw the entire graph and see where it crosses? Put in 0 for either variable. Yeah, because when I'm looking for an x-intercept, I know that the y-coordinate is 0, so I make y 0. So if my function, my equation is y equals 4 minus x squared, to find an x-intercept, make y 0. And then solve the equation. So I would move the x squared over, x squared equals 4. And then when I square root both sides, to undo the square, I should square root, right? Square root, square root. What is the square root of x squared? Be careful. Absolute value of x. So I have the absolute value of x equals the square root of 4 is 2. So if the absolute value of x is 2, what could x be? 2 or -2. Both of those numbers have an absolute value of 2. So then to finish solving, I say x is plus or minus 2. So that's how you would find x-intercepts. To find y-intercepts, you would make the x-coordinate 0, right? For any y-intercept, if you're on the y-axis, your x-coordinate is 0. So you replace the x in the equation with a 0. And we get y equals 4. So you can find intercepts graphically, algebraically. And now I'm going to show you how to do some stuff in your graphing calculator. How to graph that equation and how to find the intercepts on your calculator. All right, so take out your graphing calculator. Everyone should have one by now. Okay, so we get the graphing calculator open. I want to graph the equation 4 minus x squared. We already graphed it by hand. Yes. I'm just going to have to follow along then. Try it at home when you get home. Okay, so I want to graph 4 minus x squared. We've already done it by hand, so now we're going to learn how to have the calculator do it for us. So we go to y equals, upper left button. If there's anything in there you want to clear it, just press the clear button. It's on the right. And you're going to type in y1, 4 minus, and then the x button is diagonal from the yellow second button, or green, blue or green, depending on your calculator. Diagonal from the second button. It says xt theta n. That's like your variable button. Okay, so if you want to put in an x, you press that guy. And then to square it, it's on the left-hand side, about halfway down is the x squared button. Or if you wanted to cube it or raise it to the fourth, you could use this little caret on the right. So if I could also write caret 2. means raised to the second power. Okay, so I've got 4 minus x squared in my y equals button. I want you to press graph. The graph button is in the upper right here. And I have a pretty decent picture. Not everybody will, because the next thing you have to do is choose a good viewing window. Okay, so the coordinate plane from the first thing we did here, this coordinate plane, is infinite. The x coordinate, the x axis and the y axis both go on forever. And the window of your graphing calculator, your viewing screen, is finite. So you have to decide where on the coordinate plane you want to look at. So in order to choose, it's called a window or a viewing rectangle. We go to the window button. So along the top, you choose window. -10 to 10 for x min and x max, and -10 to 10 for y min and y max are the standard places to start, but it's not always going to be a good window. I always leave my scales at 1. That's just how big a tick mark is. I always leave them at 1, but you can play around with them if you want. So I'm just going to leave them -10 to 10, -10 to 10 for now. And then press graph, and you see that it looks the same as the picture we drew by hand. Anybody having a calculator issue? Okay. So a shortcut for getting to that standard window, and this is notation for a window, and it means whenever you see those square brackets and they're referring to a window, you read it as x min, x max, x scale, y min, y max, y scale. That's what the notation means. So a shortcut to get that standard viewing window is to press zoom 6. So the zoom button is along the top. Option 6 is Z standard, and that automatically gets you -10 to 10, -10 to 10. You can also use the zoom menu to zoom in and out, right? So let's choose option 2, zoom in. And you can put the cursor on the spot you want to zoom in on. I'll just have it on the origin, and it zooms in. You can also zoom out that way. All right, so to have the calculator generate a table of values for you, we did this by hand in the very beginning. To generate a table of values, you press second graph. Above it, the graph button, it says table. So you hit second graph, you get a table, and then you can type in x values. So I could type in 1, 2, 3, 0, -1, -2, -3, get the y values. And I believe I showed you last class how to be able to type in x values. If you can't, you just go to table set and make sure independent is set to ask and dependent is set to auto. All right, so that's how we get a table of values. We'll skip absolute value of x. Your TI can help you find x and y intercepts. So to find y intercepts, while you're looking at the graph, I'm going to do zoom 6, get a standard window. So I'm looking at the graph. I'm going to press second trace, which is the calculate menu. Second trace. And option 1 is value. So you choose value. And it takes you back to your graph, and it's prompting you to give it an x value. So if I want to know the y-intercept of my graph, what x value should I give it? 0. Good. Because when x is 0, you're going to be on the y-axis. So you type in 0, and it gives you the y-coordinate of 4. So that's how you can get y-intercepts on your calculator. And then to get x-intercepts, we're still looking at our graph. Again, you go second trace, the calculate menu. Choose option 2 is 0. So 0 is just a synonym for Xintercept. So when you're looking for Xintercepts, you're looking for zeros. So you choose option 2, 0. And then your calculator is prompting you to give it a left bound. Okay, so that means take your cursor and move it anywhere to the left of the 0 that you're interested in. So let's say I'm looking for this Xintercept that's at -2. We know it's at -2 now, but pretend we don't. Okay. So it's asking me to put the cursor to the left of that Xintercept. So you can only move the cursor with the left and right arrow keys, so keep that in mind. And just put the cursor anywhere to the left and press enter. And then for the right bound, move the cursor to the right of the Xintercept, anywhere to the right, and press enter. And then it asks for a guess. So you see you've created a left bound and a right bound. You've got these two little arrows here. So you've given your calculator a place to search. You're saying search here for the Xintercept. And now you just have to give it a place to start searching. So you put it near the Xintercept. Theoretically, the closer it is to the Xintercept, the faster it's going to find it. But it's a calculator and it's fast, and we can hardly tell the difference. So we have a 0 at -2. If there's more than one 0, you just have to repeat the whole process again, looking for the other 0. It's going to find the closest one to the guess, because it just searches systematically until it finds one. That won't matter because it's looking for an Xintercept. So if it's just going to completely ignore the Y-intercept. So we found the same two Xintercepts that we did algebraically using the graphing calculator. So the graphing calculator is a really nifty, handy tool, but there's an even better one, and it's free, called Geogebra. So we're going to open a web browser, and this is the program that you're going to use using the Chromebook or your own laptop if you have one after you take the quiz. So you go to geogebra.org. And if you have your own laptop, you can download this software if you want, so you don't have to run it through the internet. I'm just going to run it through the internet right now because it's quick. Software. So there's a Google Chrome app. That's what we're going to use on the. I'm going to use the GeoGebra web application. Just opens it in a browser. Okay, so I want to graph in GeoGebra this equation, y = 4 - x squared. Same thing I just did by hand and on my TI. So I go to GeoGebra. There's this input bar at the bottom. Type any equation you want. Y = 4 - x squared. And you also use the caret in GeoGebra, same as in the TI. And you press enter, and there's your graph. And finding a viewing window is really fun in GeoGebra. You click this little move button, and you can just click and drag. Right? You can move it around. And when you put the cursor right over an axis, you can scale it. Ooh. Like that. And we could do the same thing for Y. Like that. So we have the perfect viewing window. And then let's see. So to generate a table of values, you open the spreadsheet. So it has a spreadsheet option. So you go to View. View? What was it? Yeah, View Spreadsheet. View. Oh, you're right. Yes, thank you. View Spreadsheet. So it opens up a spreadsheet over here. And if I want to make a table of values, I could type in, say, -3, -2. In what? No, I don't. So if I choose these two, I should be able to. Oh, it doesn't know. Oh, nope. I know how to work a spreadsheet. I got it. Okay, so now I have those two selected. If I drag it down, it should fill in a bunch of consecutive values like that. You could also just type them in by hand. Okay. All right, and then for B, I want it to calculate 4 minus x squared, and the A column are my x's. So I'm going to type equals. This is just how you work a spreadsheet in general if you've ever worked with Excel. So I want to do 4 minus this number, so I click it, squared, and I hit caret 2. What? Is it just being slow? Or was it all highlighted? Ah, shoot. Equals 4 minus this number. Caret. What? Why is that happening? Click what again? Oh. Wow, it's okay. I finally wrote it. So now that I'm in there, hit enter. And it does 4 minus the number squared. Okay, and then when that's selected, you can just drag this down and get a whole table of values. I just programmed it that way. I just put the x's here, and then I wrote this to be 4 minus this number squared. All right, let's see. What else can Geogebra do? I wanted to show you. That's how you make a table of values. Oh, to find the intercepts. You can either just inspect it visually, right? Take a little peek at the graph. And you might be able to tell, let me get rid of my spreadsheet. And I just want the algebra view. Got rid of the spreadsheet. Okay. This isn't working anymore. Anyways, we can look at it and you can see that the x-intercepts are -2 and 2 and the y-intercept is at 4. If it's not obvious where they are, we could, wrong view, algebra. That's what I want because I want to see my objects over there. To find the intercepts, I'm going to graph the x and y axes. So I'm going to graph x equals 0, which is which axis? That's the y-axis, because every x coordinate is 0. And I'm going to graph y equals 0, which is the x-axis. And then I can use the intersect command. Okay, there's a whole list of commands over here of like cool things that Geogebra can do. One of them is intersect. So I do intersect. And then you have to put, when you type it, it tells you what how the syntax for the command has to be. So you put a square bracket. Okay. And then you have to choose the two things you want to intersect. So I'm going to do my object C, which is my graph, and A, which is the y-axis. So I do C, comma A, enter, and it tells me that happens at 0, 4. And then I'll do it again for C and B. Intersect, square bracket, C, B, and I get -2, 0, and 2, 0. And it plots the points where they are. All right. So that finishes up the lecture.